So in last video we have studied for about the triangle, the explosion triangle, right? Here we are going to study about the explosion pentagon. Let's draw a pentagon first, okay? And what was the items involved in the triangle? First was that explosive atmosphere, EA, or we can call it hazardous area. We already knew about it. And another thing is involved is ignition source, right? Without ignition source, of course, it will not happen. And the third important factor is oxygen. Now, there are two more factors is involved. So this triangle was for gas, particularly. Now the pentagon is for dust. So, right? So now we are talking about the dust atmosphere. This pentagon in this area, in this pentagon, this is called dispersion, and this area is called confinement. This triangle we already knew about, but these two items added in the case of dust, that is dispersion and confinement. What is the definition of disperse and confinement? First we study that and then try to understand this this pentagon. But what is dispersion? As name itself suggests, something dispersed in air is called dispersion. But in technical language, if so, dispersion happens if a finely divided particle of explosive material dispersed in air, dispersed in atmosphere, is called dispersion. It's very simple. But that should be to ignite it, to get it explosive dust, to make it explosive dust, it should be having in a sufficient quantity and concentration, right? If I read the definition, dispersion happens when finely divided particles of explosive dust disperse in atmosphere, and that should be in sufficient quantity and concentration. So if the dispersed dust is not in sufficient quantity or in sufficient concentration, the explosive atmosphere will not happen. The explosive atmosphere will not be created, right? Likewise, in the ignition triangle, in the explosive triangle, we know that ignition cannot be happening if the ignition source is not there. So ignition source is needed for this atmosphere, this dust, explosive dust atmosphere to happen. Similarly, if we study about the confinement, what is confinement? As per the above dispersion, we understand from here, we understand that dispersion happened. How it happened, we all understood now. But now the next point is confinement. Dispersion happened in an open area. Dispersion happens in open area. Then what will happen? Wind will be there, ventilation will be there. Of course, in that area, the explosive atmosphere will not create. Will not create. But if the dust is formed, the dispersion is formed in a confined space, like in a closed area where there is no ventilation, there is no ventilation or there is no wind flow through it, right? In a confined space, then in this case, this area will become highly explosive because of the dispersion of the finely divided particles of explosive dust in atmosphere. This area becomes explosive. This area becomes explosive. However, this area will not become explosive. So this is the mainly definition of confinement. If the dust cloud has been dispersed in sufficient quantity and concentration and is confined or semi-confined in a vessel, what these areas can be? These areas can be a vessel, like room or building, anything. Then it burns very rapidly. Then this dust cloud burns very rapidly and also explode. So now we understood the definition of confinement and the definition of dispersion. What is dispersion? We understood that the dispersion happens when finely divided particles dispersed in atmosphere in a sufficient quantity and concentration. So this is the definition of dispersion. Then only that dust particle will become the explosive, right? And as far as confinement is concerned, it's just that simple. If the dust which has been dispersed in air has to be in a confined or a semi-confined space. If it is an open space or in a proper ventilated space, the dispersed dust will not be an explosive. Okay, so that we understood now. And what are those confinement spaces? Those can be a vessel, those can be a room or a building, anything. And also to get this ignite, we just need the ignition source. If you are having an ignition source and you have the dispersion of dust in a sufficient quantity and concentration in atmosphere, and if that area is not confined, if that area is open, ventilated, the wind is there, then the explosive atmosphere will not be created. However, at the same time, if it is a confined space, so Pentagon suggests the same. If it is a confined space, the fifth item, confinement. If it is a confined space, it means there is no ventilation, the wind is not there, it is in a closed room, and and that if this dispersion happens, so it is going to burn very rapidly and also will cause a very heavy explosion as well. Moving further, we can study about the dust explosion in more detail. Dust explosion detailed. How it happening? So I can say here there are two type of dust explosion happens at a single place. First is primary dust explosion and the second is secondary. We need to understand here that primary dust explosion and secondary dust explosion, it's not the two type. It's that it's just the form of explosion happens at the same place, one by one, simultaneously. First primary explosion happens in an industry and then secondary takes place. How it happens? If you try to understand that in more detail, primary dust explosion in an industry usually involve a dust cloud, dispersed dust, which we already studied about. That is ignited by an ignition source. Okay, what is primary dust explosion? The dispersed dust which is already there in the environment, and if it gets the ignition source, it will ignite and explode. That is called the primary dust. However, at the same time, the secondary dust explosion, how it happens? In industry, what exactly happens when primary explosion happens in a suppose in an area. It can happen at anywhere, right? It can happen anywhere. So when it happens, the settled dust in different area of that room or around the building, because when there is explosion, it's a big explosion. It's always a big explosion even in a single room. So the dust settled in the beams, high sleeving machineries, right, and over the fans, over so many places. If the dust is settled there, and once the primary explosion happens, those dust starts to dispersed in air, dispersed in air, and and that causes secondary explosion. Okay, that caused the secondary explosion. The collected dust and debris will be dispersed by the primary explosion, which in turn cause a much larger explosion that is termed as secondary dust explosion. Okay, and also if we talk about the secondary dust explosion and the dust layer settled on the surface of beam, columns, high sleeving or machineries, as little as 0.8 mm dust layer when dispersed in air is sufficient to cause an explosion. This is how come secondary explosion happens. Now we are going to study about the chemical composition of these dusts. So for the gases and dust to be explosive, it must be combustible. That we all know. That is, it must be able to burn and it should be able to release enough heat for burning. So, for the gases, dust to be explosive, it must be combustible, first of all. And that is, it must be able to burn and it should be able to release enough heat from the burning to be sustained. Right? For example, flammable gases. Gases. What are the gases includes? That is methane, hydrogen, ammonia, propane, ethylene, acetylene, etc. And what about the flammable explosive dust? So these are the item which are explosive, comes under explosive dust. First is most organic materials, that is wheat, sugar, maize, wood. Second is metals, that is aluminum, magnesium, titanium. Third is non-metals, that is sulfur, silicon. And we just studied about the gases, flammable gases, that is methane, hydrogen, ammonia, propane, ethylene, acetylene. Some of these materials are normally combustible, but they can be burned or explode if the particles are the right size and in the right concentration. Any activity that creates fine dust must be investigated for its explosive nature.